Hi there, welcome to BrilliantMaths.com, where every student has an opportunity to excel in mathematics. Are you still struggling with mathematics? That means you're not taking advantage of all the resources we have for you on BrilliantMaths.com. Subscribe to the website, subscribe to the modules. There are lots and lots of exercises for you to practice and ensure that you excel in math. Today's lesson is taken from Brilliant Maths Module 2. Get a copy and let's work together. The lesson today is decimal numbers, and we're looking at value and place value. Decimals come from the Latin word called decimus, meaning tenth. The decimal system is in base 10, and the decimal point separates the whole numbers from the decimal numbers. All the numbers after the decimal point are fractions. The first decimal number has a place value of tenth. The second is a hundredth. The third is a thousandth. And the fourth is 1/10,000. They are very small numbers. So the further the number is from the decimal point, the smaller it becomes. The numbers before the decimal point are whole numbers, just like we know whole numbers already. The first digit closest to the decimal point is the unit. The next is a tenth. The next is in hundreds. And the next is in thousand, and so on. Today we want to learn how to write or find the value and place value of all the digits in decimal numbers. The first number we have is 8,701.3589. Listen to how I called out the number. 8,301.3589. I called it 3589 because they are all decimal numbers and they are less than 1. We want to put that number on the place value chart that we have on the board. So the value of the 8 is 8,000. So it comes under the thousand column. The value of the 7 is 700. The value of the 0 is 010. The value of the unit is 1. And then we have our decimal point. The 3 after the decimal point is 3/10. 500th, 8,000th, and 9/10,000th. So the place value of the 8 is 1,000, the 7 is 100, the 0 is tenths, the 1 is unit, and the place value of the 3 is tenth. The place value of the 5 is hundredth. The place value of the 8 is thousandth. The place value of the 9 is 10,000. But the values of these digits will be 8,000. So the value of the 8 is actually worth 8,000. The 7 is worth 7 hundredths. The 0 is worth 010 or 0. The 1 is worth 1 unit. The value of the 3 is 3/10. So it's 3 out of 10 is less than 1. The value of the 5 is 5 out of 100. The value of the 8 is 8 out of 1,000. That's a very small number. And the value of the 9 is 9 out of 10,000. Let's look at the second number, 461.03. So we have 400, 6/10, that's the value, 1 unit again, the decimal point, 0/10, and 3/100. It's very easy. The place value refers to the column that the number is written under, while the value of the digit is the worth of the digits. So for example, the value of the 4 is 400, while the value of this 3 is 3/100th. That is 3 out of 100. Let's look at the third number, 0.1046. What is the place value of the 1? The place value of the 1 is 10th. The place value of the 0 is 100th. The place value of the 4 is 1000th. And the place value of the 6 is 6/10. And the place value of the 6 is 10,000. What is the value of the 4? The value of the 4 is 4/1000. That's the actual worth of the digit. Let's look at number 4. We want to write the number 417/1000 as a decimal. What would it be? 4 is a whole number, so 4 is in the unit column. 17/1000 has 7 thousandths and 1/100th. So the number would be 4.017. Look at it again. 4 units, 7 thousandths, 1/100th, and 0/10th. Just play around with these numbers and watch the video again. It will help you understand better. In this example, we want to learn how to compare and order fractions. We're going to use these two examples to compare and order fractions. Example 1. Write these decimal numbers starting with the largest. So we have 3 decimal numbers to compare and then write in order starting with the largest one. To compare decimal fractions, look at the highest, the value or place value of the highest digits. Here we have 0.5. The second number is 0.504, and the third number is 0.404. So I write down the 3 numbers. The first one is 0, or 0.5. And then we have 0.504 and 0.404. All of them start with a 0. So we can't tell by just the first digit which is the largest. Let's look at the second digit. The second digit here is 0.5. That's 5/10. The second digit in the second number is 5/10. But the second digit in the third number is 4/10. So 0.404 is the smallest of the 3 numbers because 4 is smaller than 5 and the first 2 have 5/10. So let's compare the next 2 to see which is the largest. 0.5 and 0.504. So the largest is 0.504 and then the next is 0.5 and the smallest of the numbers is 0.404. So you compare by looking at the digits on the various. So you compare by looking at the digits in the different place values. So largest, 0.504. Then the next is 0.5. And the smallest is 0.404. So writing it in order, we have 0.504, 0.5, and 0.404. The second example says, order these decimals from least to greatest. So here we want to start with the smallest. Let's write out the decimal numbers. So we have 3.87, 3.0875, 3.807, and 3.87502. We're starting with a list. So list to greatest. Let's see which one is the smallest. 3.3, all of them start with 3 in the unit place. So we go to the next place value, the 10th column. The 10th column here has an 8. The 10th column here is a 0. 10th column here is an 8, and 10th column here is an 8. So the smallest is 3.0875. I'd like to strike that off since I have written it already. Let's see the next. 3.87, 3.80, 3.87. So the next smallest is 3.80. There's a 0 in the 100th column, and there are 7s in the 100th column of the other two numbers. So the next number is 3.807. I strike it out. The next number will be 3.87 because it terminates there. And then the largest will be 3.87502. So I have 3.87, and then finally I have 3.87502. It's very easy to compare decimal numbers. Just compare by checking the highest place values and go from one place value to the next until you see where they are different. Next, we want to look at terminating and recurring decimals. When do we say a decimal is terminating or recurring? At the end of the examples, we'll be able to tell the difference. Write 3/8 as a decimal. 3/8 actually means 3 divided by 8. So we're going to divide 3 by 8 using long division. 3 divided by 8, 3 cannot be divided by 8. So we'll put a 0 and we'll put a decimal point. Then we can attach a 0 to the 3 to make it 30. 8 into 30 is 3, because 3 times 8 is 24. You subtract, and that gives you 6. We put a 0, attach a 0 to the 6, it becomes 60. 8 into 60, that means 60 divided by 8, and that is 7. 7 times 8 is 56. We subtract, and that leaves us with a 4. Attach another 0. 8 into 40 is 5. 5 times 8 is 40. And that ends our subtraction. So 3/8 is equal to 0.375. This is an example of a terminating decimal because it ends here. In example 2, we have write 2/3 as a decimal. 2/3 means 2 divided by 3. So we use long division. We are dividing 2 by 3. 2 by 3 is a 0. We put a 0 and write a decimal point, and then attach a 0 to the 2. We put a 0 and write a decimal point, and then attach a 0 to the 2 to make it 20. 3 into 20, we have 6 3s in 20. 6 times 3 is 18. We subtract. If you subtract, you have 2. So again, we attach a 0. 3 into 20 is 6. 6 times 3 is 18. 20 minus 18 is 2. We attach a 0 again. 3 into 20 is 6. 6 times 3 is 18. 20 minus 18 is 2. It just goes on and on and on. This is an example of a recurring decimal. It continues and will never stop for as long as you continue. So to show that the decimal is recurring, you put a dot on top of the last digit you write. So 2/3 is 0.666. That dot shows that it's recurring. So that's an example of a recurring decimal. In this example, we want to learn how to add and subtract decimal numbers. The addition and subtraction of decimal numbers follows the same principles as adding and subtracting whole numbers. The only difference is decimal numbers have decimal points. So you have to align the decimal points so that the digits in the numbers will fall in the correct place values while you add or subtract. Let's look at the first example. It says 2.395 plus 17. So 17.08. It's important that the decimal points are on a straight line. 6.85. With this, it becomes easy to add. You could add zeros as placeholders here. So 5 plus 0 is a 5. 9 plus 8 is a 17. And 17 plus 5 is 22. So we carry over 2. 8 plus 2 is 10. Plus 3 is 13. We carry over the 1. And we put our decimal point. So 1 plus 2 is 3. 3 plus 7 is 10. 10 plus 6 is 16. And then we carry 1. 1 plus 1 is 2. So the sum of those numbers is 26.325. Make sure you align. That's the most important thing here. In the second example, we want to subtract 18.9314 from 87.62. Again, align the decimal points. It must fall on a straight line. 87.62 and 18.9314. We want to take away. We're subtracting. So here, we must write the zeros as placeholders for those place values, those columns. To take away 4, we have to come and borrow 1 from the 2. So we borrow 1, and we're left with 1. It becomes 10. We borrow 1, and we're left with 9. Then we have 10 take away 4, which will be a 6. 9 take away 1, that will give us 8. 1 take away 3 cannot, so we borrow from the 6, and we have a 5 left there. It becomes 11 take away 3, and we have 8. 5 take away 9, we can't, so we borrow 1. We're left with the 6 there. It becomes 15 take away 9, and we have a 6. Decimal point, as you can see, the decimal points are aligned. 6 take away 8 cannot. We borrow 1 from the 8. It becomes 16. 16 take away 8 is 8, and 7 take away 1 is 6. So the answer, the difference between the two numbers is 68.6886. Very easy concept. Work some more examples from Brilliant Maths Module 2. In this example, we want to learn how to multiply and divide decimal numbers. Multiplication of decimal numbers follows the same process as multiplication of whole numbers. The only difference is a decimal point, and we'll find out how it works. Example 1 says 3.54 times 1.8. So we're ready to multiply. 8 times 4 is 32. We carry 3. 8 times 5 is 40. Plus 3, that's 43. And 8 times 3 is 24. 24 plus 4 is 28. We're multiplying by 1. 0 placeholder. You write it there. 1 times 4 is 4. 1 times 5 is 5. And 1 times 3 is 3. Then we add. The final answer, or the product of the two numbers, we have a 2 there. 3 plus 4, 7. 8 plus 5 is 13. Carry 1. 2 plus 3 is 5. Plus 1 is 6. But we have 2 decimal places in the first number and 1 decimal place in the second number. So you count the number of decimal places in both numbers. So we have 1, 2, 3. Then count 3 places of decimal from right to left, from the last digit going towards the left. So we have 1, 2, 3. And place the decimal point there. So 3.54 times 1.8 is equal to 6.372. Example 2, 0.4812 divided by 0.4. Before you can divide, change your divisor into a whole number. Multiply by a power of 10. That would make your divisor a whole number. So you multiply both numbers. So here we have to multiply both numbers by 10. We're multiplying both numbers by 10 because the divisor is 0.4. So we multiply 0.4 by 10 and it becomes 4. 4 is a whole number, and then now we can divide. From the digits, I don't really have to use long division. I can do this using short division. So the answer is equal to 4 divided by 4 is 1 point. 8 divided by 4 is 2. 1 divided by 4 is 0. And 12 divided by 4 is 3. So my answer is 1.203. If you multiply 1.203 by 0.4, you should get 0.4812. Try it out, and you would see that it's correct. In this example, we want to learn how to multiply and divide by powers of 10. So by 10, 100, or 1,000. Example 1 says 0.96 times 10. When you multiply any number by 10, the number gets 10 times bigger. If you multiply a number by 100, it gets 100 times bigger. If you multiply by 1,000, it gets 1,000 times bigger. So 0.96 times 10. If the number gets 10 times bigger, the answer will be 9.6. There's an easy way of just moving the decimal point around to get your answer. But in the real sense of it, the decimal point does not move. It is static. It's only the digits that change place value when they're either getting bigger or smaller. So 0.96 times 10, we're multiplying, so the number is getting bigger. So the place value of this 9 is going to change from 9/10 to 9 units. So we practically kind of move the decimal point there. So it becomes 9.6. It moves one place because you're multiplying by 10. When you multiply by 100, it will move 2 places. Actually, in the real sense of it, the digits change place value because the number is becoming 100 times bigger. So 81.18 times 100 becomes 8118. That's the answer. The place value of the original digits is 8 tenths and 1 unit, and then 1 tenth and 8 hundredths. But when you multiply it by 100, it becomes, the values now become 8,118. So this 8 has changed place value from 8 tenths to 8,000. The 1 has changed position from 1 unit to 100. This one has changed position from 1 tenth to 1/10. So it's now 10 instead of a tenth. And then the 8 has changed position from 8 hundredths to 8 units. So the number is now 100 times bigger. For the last one, 1.2 times 1,000 is going to get 1,000 times bigger. Here we have loops without numbers, and we will put zeros there. So the answer will be 1,200. So 1.2 times 1,000 is equal to 1,200. It's a very easy concept. Just play around with it. The second example, we're dividing. So when you're dividing, the numbers will get smaller. When you divide a number by 10, the number will get 10 times smaller. So like we explained in the first one, the positions of the digits will change. So we'll put the loops as though the decimal point is moving, but the decimal point in actual sense is not moving. So 2.57 divided by 100 is going to get 100 times smaller. So the loop goes from right to left. We have 2 loops. So that the answer is 0.0257. For the second one, 1.2 divided by 1,000, 3 loops, 1, 2, 3. So it becomes 0.0012. And for the third one, 0.842 divided by 10 becomes just 1 loop, 0.0842. You'll get more of this from Brilliant Maths Module 2. BrilliantMaths.com is for you. Subscribe to it, subscribe to the website, subscribe to the modules, and you'll be happy you did. There are lots and lots of exercises, practice, and videos for you to watch and excel in math. My name is Ngozi Orevogene, and always remember that maths is fun and you can do it.